Hey guys, here is the whole of geometry for your GCSE Maths for you. Now, to go with this, over on my website there is a free revision guide which has all the statements at the top of their slides for you to go through. Check which ones you know, check which ones you don't know, use a video to either work out which bits you do or don't know, fix any problems, and then once you've done this you can go through the exam papers. Try and fix any problems, work out which bits you thought you were okay with but you're not okay with, or which bits you didn't think you were okay with but actually you are okay with. Try some of the quick questions, and don't forget the exam boards are so similar to maths that once you've done all the papers for your exam board, go and check out a different exam board's paper because it covers the same content just in a different front cover. That's it, there's the only difference. So good luck guys, hope you find this helpful. Once you've done this you can go and check out all the other topics as well. Some nice definitions to start us off here. Point is going to be the point of the shape where two lines meet. A line is going to be a thing connecting two points. Vertices, that is going to be the point, or on an ellipse, your vertice is going to be the point of steepest angle. An edge, again, is along here, and then a plane is going to be a flat surface that goes in all directions. Here we have some parallel lines, here we have some perpendicular lines, and a right angle can be indicated if we just draw a little box in the corner there. Parallel lines can be shown by little arrows going like this, and if we look at our equation for a straight line, parallel lines are going to have the same gradient, so m is going to be the same on both of them. For a regular polygon, we're going to have all sides being the same and all angles being the same. And if n is our number of sides, we can find the sum of the interior angles by doing n minus 2 times 180. This applies whether it is a square or a regular pentagon, regular hexagon, whether hexagon, octagon, nonagon, etc, etc. When we reflect something, we can flip it or reflect it across a line, creating a mirror image. Rotational symmetry is when something looks the same as it did at the beginning after you've turned it round a little bit. If you want to draw a perpendicular bisect of a line, you need to open your compass, really wide. And we're going to start by putting the point of our compass on A over here. And what you need to do is draw a big circle. So a big arc that goes around like this. Switch your compass point so it's over on B. Again, draw a big arc from B. And then this point and this point here are the points that are important. You need to join these two up with a pencil and a ruler, a sharp pencil, a ruler and a compass. Obviously I know I'm not doing that, but you need to do that in your exam. And then this line here is going to be your perpendicular bisect. For loco problems, you may be given a scale that you have to use, so you're going to need to set your compass and your ruler to that scale, or you may not be given one. What you're generally going to be asked to do is to draw a circle around point A with a compass, not roughly like I'm doing, and then a circle around point B, again with a compass, not like I'm doing, and see where those two intersect. But the really important thing here is accuracy with compasses, accuracy with rulers. So if your ruler at the moment is covered in Tipp-Ex, is broken, the markings have come off it, please go and spend 50p, £1 getting yourself a decent clear ruler. Or if you can't do that, go and talk to your head of year or your form tutor or your maths or science teacher, and they will generally be able to help you. If we have angles that all meet at a point, A plus B plus C plus D are going to equal 360. If they are on a straight line, A plus B is going to equal 180. If we have vertically opposite angles, they are equal. When we have parallel lines, our corresponding angles are equal. Don't forget, this is also going to have alternate angles, and they are also going to be equal. and it is going to have alternate angles. Now, the example does not like you calling these Z angles, but they are also going to be equal. So if we could use the terms corresponding angles and parallel lines, alternate angles and parallel lines, vertically opposite angles, just don't call them by colloquial terms like Z angles. And all the angles inside a triangle add up to 180 degrees. A square is a regular quadrilateral. It's going to have equal sides. It's going to have equal angles. These are 90 degrees. These are right angles. Its area is the two sides multiplied, so that's going to be x squared for this. The perimeter is 4x, and the length of the diagonal is just going to be x times the square root of 2. A rectangle is going to have two sets of equal sides. So this is going to be equal and these are going to be equal. But the angles inside are going to be equal. And again, they are going to be right angles. Its area is one side times the other side, so length times width. And its parameter is 2x plus 2y. A parallelogram is like a slightly skew-width triangle or rectangle. For the parameter, we need to go all the way around the edge, so that is 2x plus 2y. For the area, we need the base times the height. It is going to have two sets of lines that are the same. The opposite angles are going to be equal, and angles A and angles B are going to add up to 180. For a trapezium, we're going to have four random sides. For the perimeter, it's A plus B plus C plus D, so going all the way around the edge. The area is half the top, the bottom times the height, and then the top and the bottom are just going to be parallel. For a kite, we're going to have two sets of lines that are the same. So our perimeter is going to be 2x plus 2y. Our area is going to be half A plus B, so that's the height times the width. And we're going to have one set of angles that are the same. For a rhombus, you're going to have all sides being the same, so the perimeter is going to 4x. The area is going to be half A times B, and opposite angles are going to be the same. If you want to prove that two triangles are the same, you need three pieces of evidence, and there are four different ways you can get three pieces of evidence. Side, 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 angle, angle, or right angle, hypotenuse, side. So these two triangles, even though they're drawn in different orientations, have three sides that are the same, so they are the same. For side, angle, side, the angle has to be the angle in between the two sides. So here we go, side, angle, side, angle, side, they are the same. Here we have two triangles that have two identical angles and a side that are the same, so these are the same. Our last two triangles both have a right angle, they both have the same hypotenuse, and one of the other sides is the same. For an equilateral triangle, we are going to have all sides and all angles being the same. For an isosceles triangles, we are going to have two sides being the same, and then the angles at the base are going to be the same. If you want to rotate a shape, the examiners may either tell you what to do or they may have rotated the shape and ask you what to do. You need to give the degree that it's rotated by, the direction that it's rotated by, and where it's rotated about. So we're going to rotate this shape 90 degrees clockwise, about 0, 0, and the first thing you need to do is find the first point, which for me is this point here. Rotate it 90 degrees, and then all the other points will follow on from that. If we're going to reflect a shape, they'll generally give you the line to reflect it in. Work out how far away your first point is from the line, and that will give you your second point. That will give you where your first point is the other side of the line. All your other points can reflect on from that. If you are given a translation to do, it may come as a vector. So here we need to translate by 3, 4. That means every single point has to move 3 across in x and then 4 up in y. So we are going to end up with our shape up here somewhere. If we are going to enlarge a shape, you need to know the centre of enlargement. Draw lines from your centre of enlargement through each of your corners, and then work out the distance from your centre to your first corner. Double it, since our centre of enlargement is 2, and then that will be where the corner ends up. And then your shape, drawn slightly better than mine, will end up larger and further away from your centre of enlargement. Here is the centre of our circle. The radius goes from the centre to the edge. A chord is a line that touches both edges. A diameter goes through the middle and touches both edges. Circumference is the distance all the way around. A tangent is a straight line that touches the circumference. An arc is part of the circumference. A sector is like a pie-shaped wedge of a circle. And a segment is just cutting a bit off of it. When we are talking about cubes or cuboids, you need to know the faces, the edges, the surfaces, and the vertices. For a cube, it is going to be identical on all edges, which means all 6 faces are going to be identical, all 12 edges are going to be identical, it's going to have 8 vertices. If we have an edge which is of length x, the volume is going to be x cubed, that is base times height times width, and the surface area is going to be 6 because there are going to be 1, 2, 3, then 3 behind 6 faces times x squared. A cuboid is slightly different because each of the faces are not identical. Prisms and cylinders can be thought of 3D versions of shapes that we are very familiar with in 2D. If you want to work out the surface area of these, sometimes it helps to think of these as flattened out shapes, and then it becomes a lot less intimidating, because working out the surface area of a cylinder can seem intimidating, but if you break it down into a circle and a large rectangle, well, that's not a problem at all. And to work out the volume, we need to do the surface area times the height. For pyramids, cones and spheres, the best thing you can do in the exam is to slow down and think logically about things. How many faces can you see on the pyramid, and then don't forget about the ones behind. The same for the cone and the sphere. Turning a 3D shape into a 2D shape or a 2D shape into a 3D shape can be incredibly hard to do. This is a really tricky skill. They're probably going to want you to either draw 3 elevations, so maybe top, side and front, or they're going to give you 3 and ask you to draw the 3D shape. This can be an incredibly hard skill if you are not sure about it. If you are having trouble visualizing things in 3D, or if you're just not sure about how things are supposed to look, the best thing I can suggest for you to do is to use what you have on your pencil case, the stuff that you're allowed to have in your pencil case, like your sharpener and your rubber, and try and use those to maybe try and construct some kind of 3D shape that looks similar. But this is a mental skill that you have to do in your head. It's complicated if you're not used to it. The best thing you can do is practice with this one. For maps, scale conversions, bearings, it is really important that your pencil case is up to date. So I'm talking a clear ruler that you can use that has all the divisions on it, not one that's covered in Tipp-Ex or is broken. The same with a protractor and the same with a compass. So what they could ask you to do is give you point A and point B, ask you to measure the distance between them, and say 1 centimetre is 3.5 kilometres, turn that into a conversion. They might also ask you what the bearing is. So how far around it goes from north. For that you're going to need your protractor. You need to know and use all of these formula. Now they've started off by saying you needed to know all of them. Now they've said that some of them they will give you in the exam. So here are the ones that you need to know. Volume of a cuboid. That is length times width times height. The volume of a prism. That is the area of the cross section times the length. Pythagoras. A squared plus b squared equals c squared. Trigonometry when it's sine. That is your opposite over hypotenuse. The area of a triangle, that is half base times height. The area of a trapezium, that is half a plus b, which is the top and bottom lengths, times the height. The circumference of a circle when you have the radius, 2 times pi times radius. The area of a circle, that is pi times the radius squared. Oopsie, I'm giving it away, The area of a rectangle, length times width. The area of a parallelogram, good word that, base times height. The volume of a cylinder, that is pi times the radius squared times the height. Circumference of a circle when you have the diameter, that is pi times diameter. Trigonometry when it's tan, that is opposite over adjacent. Trigonometry when it's cos, that is adjacent over hypotenuse. Speed is equal to distance over time. Density is equal to mass over volume. And pressure is equal to force over area. To help you with this, if you want to save a bit of time, you can download all those flashcards from my website. To work out the length of an arc, what you need to do is to work out the circumference and times that by the ratio. What I mean by that is the circumference of the whole thing, so 2 pi r. If the whole thing is 360, how many degrees round was the circumference? So 2 pi r times n over 360. To work out the sector area is very similar. You need to find the area of the total circle and then you need to times that by the ratio. So the area of the total circle is going to be pi r squared. If this is n degrees around, that is going to be pi r squared times n over 360. Remember, all the way around in a circle is 360, halfway around is 180. When we have similar shapes, the corresponding sides are going to be in the same ratio as each other and the corresponding angles are going to be equal. For right angle triangles, you need to be thinking Pythagoras and you need to be thinking trigonometry. So for a right angle triangle, if we have A and we have B, we can work out C by using the formula, or if we can work out one of the other sides or an angle. Now the really important thing here is labelling your angles. If we have an angle, the one opposite, labelling your sides, the one opposite is the opposite, the one next to it is the adjacent. And this is the formulas here. I'm sure there are loads and loads of brilliant ways, mnemonics that you have for remembering those. So please, please, please share them down in the comments to help other people. I strongly recommend you spend some time learning these values. They can come up in lots of different ways. To help you, I'm going to show you the video, or if you want to save a bit of time, you can get the flashcards from my website. So sine of 0 is 0, cos of 0 is 1, tan of 0 is 0, sine of 30 is a half, cos of 30 is square root of 3 over 2, tan of 30 is 1 over the square root of 3, sine 45 is 1 over the square root of 2, cos 45 is 1 over the square root of 2, tan of 45 is 1, sine of 60 is square root of 3 over 2, cos of 60 is a half, tan of 60 is the square root of 3. Sine of 90 is 1, cos of 90 is 0, and tan of 90 you don't need to know. When we are talking about vectors, it is x on top and y on the bottom. So if you want to talk about a translation, it is the movement in x and then the movement in y. If we want to add, subtract or multiply them, it's just like doing normal maths, just things are on top of each other. So if we want to add vectors A and B, first of all we look at the top line, so 1 plus 3 is going to give us 4, then we look at the bottom, 2 plus 4 is going to give us 6. Subtracting them is the same, so 1 minus 3 is going to give us minus 2, and then 2 minus 4 is going to give us minus 2. Multiplying them works in the same way, 2 times 1 is 2, 2 times 2 is 4. If you're doing foundation tier, well done, you have finished. You can move on to the next section. You can try some questions or you can try some past papers to help you apply what you've learned. When we are enlarging by negative scale factors, it is very similar to enlarging by positive ones. You just need to go in the opposite direction. So again, you need to draw your lines from your corners about your centre of enlargements. And then here, if this is 1 away in this direction, we're enlarging it by -2, so we need to go the other direction in -2. So that will go there, and then all the other ones will follow on like that. A combination of rotations, reflections and translations is going to be tricky, but just follow things through logically in the exam, take things carefully, look at what has happened to it and describe absolutely everything that's happened, don't skip any steps. Circle theorems can seem nasty, but you just need to remember the rules. An angle at the centre is going to do twice the angle at the circumference. Angles that are in the same segment are equal. The angle in a semicircle is a right angle. Opposite angles in a cyclical quadrilateral add up to 180 degrees. A chord can be bisected by a perpendicular line from the centre. The angle between the tangent and the radius is 90 degrees. Two tangents that come from the same point are equal. And the alternate segment theory tells us that this angle and this angle are going to be equal, and this angle and this angle are going to be equal. Here are the last 3 rules that you need to learn and be able to apply. So we have the sine rule, the cosine rule, and the rule for working out the area of a non-right angle triangle. So for the sine rule, you need an angle or 2 sets of angles on corresponding sides. For a cosine rule, you need an angle and then 3 sides, and you can find one of the sides or the angle. And for the area of a non-right angle triangle, you need an angle and then 2 sides.